So this evening, I'm going to share some of the practical things I've done. And the topic before us is the importance of engineering design review in ensuring a better process hazard analysis and plant design. This topic is critical because of the value is going to, or it has actually presented, before a lot of plant engineers, before asset owners. So sorry, there will be a bit in and out of people because in my room, the network is very bad. I've been on transit, just checked in my hotel. I tried to do it from the room, so but it didn't, it was so bad. I have to hook up here. So don't be distracted. Try to keep focused because you see people coming in and out. I'm just trying to manage this for the short period of time. So like I said, the value engineering design review have brought to the industry is something that we cannot actually quantify. So when we talk about engineering design review, we are talking about a workshop where a group of persons, what I would call stakeholders, critical stakeholders, but more of the technical aspect that we come together. And when I talk about the technical aspect, I'm talking about the designer of the plant. At some point, is the designer of the plant, okay, comes together and review what they have done before they even move further, before they talk about the PhD, and before they also talk about commissioning this plant. So I'm going to take you through introduction, the purpose of EDR, short for Engineering Design Review. Then I'm going also to take you through a bit of process plan design, then talk through about HAZOP and the benefits this is going to present to us. Then I will take you through some works I've done in this area, very brief work like a case study. So engineering design review, like I said, it helps to add value to plants design. And when we talk about safety, process safety analysis or process safety hazard, this has to be identified at the design stage of projects. We have to identify this and we need to get it right. It is when we get it right, we identify process hazard, then we can start talking about control before you even start talking about emergency response. So that is where it starts from. Now, before we start talking about controls, start talking about responses and all that, it's very important we need to get it right. So engineering design review, in short, EDR is intended to protect one or more precious asset a team has. Okay, so it is a way to proactively get ahead of both documentation and the system design, because we actually utilizes the basis for design, we utilizes the cause and effect, and also other engineering documents that have been put together to come up with your flow station, say to say, with your storage tanks, and so many others. So these are the things that are put together. So we need to review that. Okay. So in doing that, we need to critique that drawing. For example, for those of us that work in flow station, LPG storage tank, oftentimes you have the design company that is different from the asset owner. So the design company put these things together in terms of piping and instrumentation drawing, showing the connections between valves, between storage tanks, talking about the system control, talking about your pressure transmitters and all that. So when those things are done, then what happens? The next stage is to implement in terms of trying to construct the way it is. However, past experience have shown the fact that there are so many gaps, which is changes that comes between the PR90, which is a document, and also the construction phase. So these changes, we need to actually manage them. So this is where design review comes in before the HAZOP itself. Okay, so the main aim is to review and understand the problem areas, discuss the current solutions, identify any issues. Now, I have done over 95, I'm a chairman to over 95 HAZOPs or PhD using the HAZOP techniques for different companies. Now, one common flaw is the fact that a whole lot of companies try to use PhD as a replacement or as a basis to do engineering design review. This is absolutely wrong because one is going to impact significantly on your HAZOP study because the time is not there. The time is actually put together to come and do HAZOP, not engineering design review. But unfortunately, we find ourselves doing both engineering design review and HAZOP. But the low light is the fact that it's not going to address a whole lot of issues. So for over 24 years, for any time I HAZOP, I do a PhD. When I see engineering design review issues, I put a comment to go back to the drawing board and get it right, integrate it into the drawing. At some point, if they are very critical issues, then you have to come back and do the PhD again. So that is the importance. And in doing all this, what we're trying to do is to improve system design. The improvement of system design, identification of process hazard, will certainly lead to what? Reduction in process safety incident. Now, and when that happens, it means at some point you are running your plant efficiently with less fears, seamlessly at some point in time. So the purpose of the EDR is to make sure that the team, we are all on the same page and understand how a system is structured and how all of the various components interact. Yeah, because what do I mean here? A team comes together. We look at the design. We need to review what they call the basis for this design. For example, I come up with a tank design, and in that my tank design, I don't want to put paint. I decided to put PVROV. So there must be basis for putting that PVROV, right? So everybody must agree on the fact that the purpose for putting pressure vacuum relief valve is because, for example, we don't want to relieve any form of gas to the atmosphere. And if this is true, then it also means the fact that we need to have that documented in the basis for design. Then we start talking about the operations philosophy. So everybody must be on the page. So design reviews are not intended to be critical in nature or form a presentation. Yeah, it's not a workshop that people just come, make a presentation, and everybody claps. No, before the presentation, which is the workshop, we must have access to a lot of this document, pages for design, PR90, cause and effect, simulation report, as the case may be, calculation sheets. Okay, all this would have been looked together. Now, the team also, whoever that has been selected to be part of this engineering design review, we also have the copy of this document so that we are all on the same page. We need to read through them. We need to understand them before we come to the workshop to brainstorm and agree on a common goal on how that plan should be designed. And remember, engineering design review is benchmark to basis for design. in your basis for design document, you have stated all the code and standard that you have used to design, for example, your relief cases designed to API 520. If you have a flare, a system, flare stack, depressurization, blowdown, and all that. So you have to design to, I think, 520, 521, part 1 and 2. And we have series of these code and standard. So we need to look at them one by one. So it's not just a workshop that people just come spend 3 minutes and they say, okay, we're done with design review. It is not just looking at that. Okay, so it goes beyond that. And that is why ahead of time, people need to have this document at hand and go through them. And it is not also for babies in terms of the greenhorns that are just coming to the industry. You can be part of it to learn, but if a greenhorn is a major participant of engineering design review, then I can tell you for free without consulting me that you are not going to come up with anything very good, substantial, up to an extent that is going to positively affect that design. It is no, no, no. And that is why we need people, experienced people that are vast in P&ID interpretation, experienced people that are vast in the interpretation of code and standard as contained in the basis for design for us to discuss. You can't come to engineering design workshop and you don't even know about pumps, you don't know about the code and standard, you don't know about how pumps work, how storage tanks are designed. So there is no basis for you to be in that workshop except you are there to learn. But like I've earlier said, if you are there as a major participant, then you are not going to make significant progress. So we need to get this right. When is it necessary to carry out EDR for small and big projects? For new projects, when you are carrying out a review of projects, management of change, modifications, we need to look at the impact. Then we need, when an external data contract change is proposed, in a nutshell, MOC is very important. When significant changes during the project phase, before you get to pre-startup, pre-commissioning, and commissioning that plan, it is important we review. It's a significant change to existing design and deployment, right? So why do we actually need to perform that? We need to clarify requirements. I will start sharing some of these critical cases I have handled in the industry. At some point, the designers are very bitter with me because they felt I'm coming there to shut them down because of what they have done. But the truth is, it's very simple. In your basis for design, you have stated clearly that you are designing to API 14C. And API 14C says, for example, for every pump, at the suction of the pump, you must have what? A strainer. Why at the discharge of the pump, you must have a check valve. And he also talks about the fact that for relief valve sizing philosophy, if I'm sizing my relief valve, especially for fire case, I think it should be 21%. So if you have had that in your basis for design and also in your operations philosophy, and what you have designed is not correlating, then it means you are deviating from best industry practices, which is mandatory for standard. So that means engineering design review is going to bring up all those things. So it is also good for onboarding new engineers, okay? When new engineers comes, if we are lucky and we have a design workshop, then what happens? Right from the beginning, they take you through the process from the feasibility studies at some point, depending on the scope of the engineering design review. Production contribution is also an aspect. When is a design review necessary? We've talked about its changes, significant changes requirement. So it is actually driven by change. Who are the people to participate? Anyone is welcome to participate in the review, but it has to do with the role you want to play. I can't bring in a greenhorn, somebody that is just joining without experience as a major participant. No, I would rather bring that person to come in and learn. And that is one of the things I've done for many years. For every workshops I facilitate, including engineering design review and PhD, I bring in you guys and the learn. And of course, you agree with me that it's different from the classroom setup. So no typing except for note-taking sections are recorded and archived. Yeah, only those who have read the supporting documents before the meeting may participate. The word is over may, because it's so sad that the way we handle things in this part of, I don't know the other African continent, but especially in Nigeria, it's really, really sad. Somebody's coming for PHA, which is hazard or failure mode effect analysis. He doesn't even know that he's coming for this meeting. He has not seen the design. He has not seen the basis. There are so many operators today operating in the industry. They have not set their eyes on basis for design. Even the operations philosophy, if you walk them through, interrogate them correctly, take them through the process, you find that many of them are operating as against the operations philosophy. So the first thing to get it right, identify your stakeholders and who are the typical participants. We'll talk about the processing. These are the guys that are involved in the real design that comes up with the code and standard as applied to the client. I just got a call to do a engineering design for just a mini CNG 250 bar plant, and I was asking the guy so many questions and all that. And he said he doesn't even know that this is very in-depth and all that. So first, you need to get people that are conversant with this process. Instrumentation and control for safeguarding memorandum, philosophies, and all that. So you need instrumentation and control. Most of the safeguards in the process industry, they are more of instrumentation and control. Logic in terms of program, electronic and electrical systems. Okay, then you have your safety engineers, technical safety. For occupational health and safety that are biased in terms of technical stuff, yes, fine. But otherwise, I have seen, to be candid, I've seen so many occupational health and safety guys struggling. They don't even know the process for PhD, let alone design engineering review. And these are, at some point, a gate for them to actually wade in and to say, see, before you even talk about hazard, you need to do engineering design review. So not until we are safety professionals, permit me to use the word wake up, because today, hazard and so many other things are not under safety. Because, and the truth is, I've always repeatedly said this, nobody, I repeat, no one will come to you and give you as your own baby. And I'm not saying you need to fight, but if you don't make yourself relevant, you don't make your department relevant in coming in and interject at some point, then you will continue to be irrelevant or almost taken for granted in terms of these technicalities of hazard and hazard. Because many companies, a lot of safety professionals, they can't even put scope of work together. And you see the engineering department, because of late project schedule, they want to fast track so many things. They fast track it. They even want to do away with it. You have a project of multi-million dollar project. They've done everything. When it comes to safety, they will tell you, no, 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 it's not necessary. And you are there. You can't challenge a bad process because you don't know about it. You are just blank about it. And the truth is this, if any accident happens, what is the conclusion? The safety standard of this company is poor. Who is the first person to think of in terms of being fired? It's a safety manager. The company, the director, the management don't know what is process safety. They don't know what is occupational health and safety. What they know is a safety manager. However you want to manage it is in your ball. So when something wrong happens, you cannot escape it. And that is why we need to know about these processes and have to challenge the process that will negate this best industry standard. Now, how do we not carry out this engineering design review? We need the background information. For example, if it's a flow station, we need to know the location, the geographical area. We need to know the fact that we are coming to do the what's it called now, the basis for this operations philosophy. We need to have the pipeline instrumentation drawing. We need to have plot plan, isometric drawing. We need to have the basis for design before we come talking about engineering design review. Details of engineering, calculation sheets, sometimes simulation report. I'm going to share something with you on our mine plan that we all did the engineering design review. The guys in US, they apologize at the point when we critique it. Unfortunately, we are combining it with hazard, which is not supposed to be. And like I said, the low light of combining engineering design review with PHA, which could be hazard, failure mode and effect analysis, failure tree analysis, or inventory analysis. The low light is always the fact that so many things will be left unattended because of timing. Okay, so these are the low lights. So usually engineering design review. So what happened is the fact that it is more efficient when third party facilitates it. Because if you have the knife and you have everything, you can do a very good facilitation. And where your boss, for example, that is the project sponsor or the project manager, is in that place, the truth is you cannot ask or critique certain things. So it's very important you bring in a third party that is independent. He doesn't have to participate in the design. So what you do is just to give him all the necessary drawings, documentations. He looks through with his own team. Then he comes back. We have this workshop. So meeting the typical meeting agenda is just the same with every other workshop. Yeah. Present the objective, the big picture. Where are we? What do we want to achieve at the end of the workshop? What are the takeaways? Next step for the systems is discussed. Questions for management. There are some takeaways that you need to go and discuss with the management because what? It involves cost. For example, I handle a PhD in Dubai, and one of the recommendations I made is to have 2 out of 3 system in terms of their transmitter, okay? And that is more efficient, and that is the best practice in the industry. So, hello, please. Yeah. Okay, all right. So, 2 out of 3. Now, when you talk about 2 out of 3, it means they are going to have 3 transmitters at against 1. But the 3 transmitters is more, how do I put it? 3 transmitter is more efficient, is more reliable in terms of voting architecture, philosophy. Now, that 3 is expensive. The project sponsor might not have that budget as an addition to add 2 more, right? So it's very important for them to go back to the management. So there are some recommendations that is something, even at the PhD workshop, we cannot take a decision on that. Okay, so let's quickly move on. So I'm going to talk through plan design so that we can seamlessly integrate between engineering design review and how we can integrate that with the plan design. When we talk about plan design, on my right-hand side, you see this picture. Yeah, this is more like a 3D, but you see the P&ID and all that. Okay, we'll talk about the plan design. Again, we design to be able to do what? Integrate risk analysis, identify those risks, process risks and other risks, and to be able to manage them throughout the life cycle of the plant, right? Right from the design, through maintenance, through operations. Even when you want to decommission, you also need to integrate those design. Of course, for plant design, it's to design to make it economic, um, but profitable economically, then also to improve safety. The safety we're talking about here is plant safety, right? And also it has to be environmentally friendly. Now, these are the major objectives or features of having a good plant design. Another one is what to be able to have them well spaced out, because spacing again by itself is safety in terms of process safety of a plant. So if this is true, the design to be economically beneficially to both asset whether the economy as a whole and to improve plant safety and also user friendly, then it now means that all stakeholders must look at this very well. So that also means that various code and standard must be put together and reviewed to ensure. Because if we don't do that, then there is a problem. Some of this problem might not surface at the design stage. They are there waiting for you at what? When you want to maintain. I went to the Gulf of Guinea and coincidentally they were carrying out maintenance of offshore production plants. They couldn't get anywhere to do what? To uh, um, to drain the oil because drain valves were missing, omitted during the design. Yeah. So it is either two things. You might have a very good engineering design review, come up with recommendations, go back to your drawings, integrate these drawings, fantastic drawings. But the other issue is what? Post engineering design review and also post PHA. And that is where at some point we talk about post hazard. And the post hazard does not really mean that we are going to come together again and start reviewing the hazard as hazard workshop. No, the post is we need to ensure during the construction the valves that are supposed to be open will be open. The drain valves that are supposed to be there, somebody saddled with this responsibility to follow up with the construction engineers to ensure that they are always here in terms of pipe size, in terms of valve sizing, in terms of the specification of valve, such that we did not agree on pound flange 2,500 that can take 250 bar and somebody changes to what, 1,500. I understand. I confirmed that it was true. An Indian guy was blown up recently during pressure testing. And what happened? The flanges, I don't know how true in terms of details, but they used a pound flange that is less than what they were supposed to use. Now, and I remember I was telling the person when we were having this conversation that in one of the classrooms, I usually do a presentation on flange analysis, choosing or selecting of flange uh, with respect to pressure regimes of different systems. For example, you can also use a pound flange, for example, of 1,500. Yeah, it can take a certain pressure regime, maybe for 200 bar. Yeah, that is fine. But the rule is you have to pressure test it. And when you pressure test is 1.5 times operating pressure. So when you look at that, you find out that you need to step up. Rather than doing 1,500, you have to do what? 2,500. I don't know how true. They said this guy, they missed it out, and what happened? They went beyond the design limit of the flange. And there was explosion and the guy died. So we have a note up here. I'm just going to take this. Yeah, this is a process plant design say. Process plant design circle. So it starts from feasibility study, where your concept, there's no concept here, but it actually start from concept of the project. If it's LNG, liquefied natural gas, bulk liquid, compressed, liquefied to 161 degrees Celsius. If I'm doing that type of project, I need tankers, I need ships, right? And all that. So that is my concept. I go straight to the visibility, right? For my visibility, what do? I have to go there. I have to look at the topography, access to the plant, communities, raw materials. Will there be ship collision? Is there piracy on that route? From there, I look at do hazard screening. What are the preliminary hazard assessment and controls I need to put there? Then from there, I move straight to what? Process design, basic engineering. Here I start talking about my simulation of pipes. Is it 2 inch? Is it 4 inch? You bring in your process engineering, you deploy your heists, talk about your pump side, yeah. You start putting things together. Then you talk about your front end engineering design, putting more flesh to it, becoming too much certain about the project, realization of the project beginning to grow from the stage, then it goes to the detail engineering. Yeah, at this point, you do hazard. Some also do engineering design review, but here it is still much young, fresh, because so many changes between feed and the detail engineering design. Okay, so it is when you do your detail engineering design here, you do your engineering design review here.
Please, can you mute yourself?
Hello. So here, just start to wrap up. You do your process, your engineering design review before you some do engineering design review here, but the final one before you do your hazard here, because from your hazard you use your what's it called now, your approved P&ID, approved for construction or approved for hazard. And before you come to your hazard, you would have frozen up your P&ID. So when for every engineering design review you do, the recommendation from the engineering design review must be integrated to revision to that P&ID. But there will be changes in your P&ID, so you need to bring them in. So that becomes the final document for PhD. Now, when you have done your PhD, there will be recommendation from when the need arises. So those recommendations, what you do is to ensure that at the pre-start or the pre-commissioning phase, you need to address them depending on the company's punch list. Now, if there are critical recommendations that is known, for example, you are not expected to commission a plant that your fire and gas systems are not ready, right? So these are known. So every company has their own punch list. From there, then take some time before it gets stable. Yeah, so by the critical point I want to make here is here. Your PHA must be done preceding or after you have done the engineering design review. Okay. So the same thing here. This is more detailed than what we're talking about here. So this is an amine plant. This, I think I did this about 3 months ago. We have some guys from the US. The designer is actually in the US. They are reps here in Nigeria. Okay, so when we are here, between the P and 90, yeah, before we are somewhere here, we utilize this lot of these process equipment sizing, yeah, electrical drawings, pipe calculation. So at a point, we had to have a conversation with the guys, the designer of their mine plant in the US, to actually send their calculations, the simulation report for some other engineers to look at. So many questions we asked. And they also have to come with different
Engineer,
design reviews.
Mr. Emmanuel.
Yeah.
Your voice is a bit low now. Your voice has been low for some minutes.
Okay, so how about now?
Yeah, better now, sir.
Hello?
Much better now,
okay,
sir. Much better.
Let me take the mic close. Yeah. So, okay, so that's fine. So this is what we did here. So typical workshop we held here. I'm the facilitator here. We have some guys from US that joined us, the designers, we have the project engineer, we have the plant operators, and you find out that the input was very significant, right? Very, very significant input. Here, why do we need
Hello, sir. We can't hear you again. Hello, sir. Can you hear me? Hello, engineer Emmanuel.
It's like the network has knocked him off.
I don't think it's the network because the slide is still on. I think he can't hear me. Maybe he's using earpiece or something. Hello, Mr. Emmanuel, can you hear us?
Yeah, I think it's best to drop a message on the chat so he'll be able to read that.
I'm trying to call him now.
Okay, so what happened here? An engineering company actually undertook this design and for the client. So the client deemed it necessary to bring in experts to review what they have done before they start the actual construction. So, and this is where I was brought in to facilitate as an independent person, because sometimes if you are part of the design and you facilitate, you could just be biased, okay? Human feelings and all that. So that's why usually you bring in an independent person. And before then, we requested for a lot of documents, engineering design reviews, talk about the basis for design. We requested for the PR90, we requested for the isometrics and all that. So in my own team, in my own office, we had a process engineer, instrumentation and control. We have electrical. Myself, I handle a lot of these roles and all that. So we work together. So we use the heights at some point, some critical area that we think necessary. The fact that, okay, it could be this, we are seeing some variance in terms of some figures. So we also run that, okay? And we're able to come up with something. For example, and we benchmark it, one critical thing, a tool or document that you cannot escape in terms of using for engineering design review. It's the basis for design. Every document, every equipment must have a basis for you designing that, and it has to be contained in a document. Okay, and that is what we use, because that is exactly what will be used to benchmark, because this is what you said you're going to do, and this is what you're doing. If you negate what you're doing, what you said you're going to do in terms of best industrial practice, then you need to go back, except there are reasons for that based on company's philosophy. And even if it's a company's philosophy, you must also make reference to that. For example, if you look at 1 minute. If you look at this is a pump, API 14C, a lot of code and standard whatsoever. A typical pumps you have what? A strainer. Okay. Yeah, so this is a strainer. However, if there are liquid here, where do you now drain the liquid? Yeah. Even here, there's no drain valve, the whole of this place. So for maintainability, there's an issue on this line here. Okay, so these are some of the things we need to look at. Okay, so but it differs. Now, this is just to run through. When we received this drawing you're seeing, this is after our engineering design review. That is myself and my team in my own office. So we came up with a lot of questions. So it is these questions we now use to populate our worksheet. Yeah, you can design your worksheet provided it captures the necessary things you have to put in place. So all these things we are looked together, the call out we are looked together, the basis for design, we are all looked together. Yeah. So we decided to come up with something like this. I'm just going to take you through one or two. What are the code and standards? We consider the API 2510, which is for LPD 520, for relief cases 610, okay, ASME B 31.3 for process piping, 2110A, yeah, have that for your fire protection system, and so many of it. So from there, we ask series of questions. As a matter of fact, when the designer of this project had that, they are bringing a company to review what they have done. And that's another international company with a massive presence here in Nigeria. But they brought me as they also hired me as the facilitator. When they had that somebody is coming to review what they have done, they said they were not ready for the review. They shifted the review twice before we even had this. Even at that, we had a whole lot of issues. So this is a typical workshop, not exactly the same thing you will see across board. Different people comes up with their, but here we have something in description of section, observation, and then deviation comments, what will be the impact on the project, and other recommendation action party. For system pressure design review, design pressure shown on MG. This is what this is more of API 14C numbering. Yeah, 100 LPG storage tank call out in piano. They have 17 bound they are call out for the PSV design, whereas on the PSV report they put 18 bar. So they have to be consistent. For example, your API 14C, API 520, your set point of your reliever usually should be at your design pressure. However, some companies don't put it at design pressure. They put it at what? A little bit above the operating pressure. If that is your philosophy, in your basis for design, you need to state it there and make reference. Otherwise, as an independent facilitator designer, I'm going to make reference to what? To the code and standard that says set your relief valve at your design pressure. So we need to get this right. So we are designing based on your philosophy and based on best industry practices of code and standard. The second one here, there was nothing, no provision for alarm and trips. Yeah, so it means Everything is manual. Now, if your intention or your design philosophy is to operate it manual, there is no problem with that. But one, you will have increase in human error. And this human error could lead to accident, and it will also threaten seamless operations of your plant. Okay, and that's why we say recommendation. We use the word consider. Now, this is one of the cases where project management, you need to go back to the project sponsor, because to automate this is very expensive. The project sponsor and the asset owner, they also need to do what cost benefit analysis. How big is this plant? How much am I going to benefit in terms of cost, revenue generated, profit? If I do all this, if they weigh it and they say, okay, sorry, we need to train, we need to operate manually for us to make profit, that's fine. There is no code and standard that says you must automate, that is mandatory. No, and that is why we are using robot shot panel as semi-automated on plants. Okay, so this is where company's philosophy also plays a very important role. Process piping, we have issues with the process piping because of the flanges they choose. So there are deliberations and we ask them to change. Yeah, but it is based on what they supplied or the information. So what it means is if the information is not correct, then that means those redesigning it, reviewing it, will also have some issues. There is no vapor return line. Yeah, so we ask them, how do you manage this vapor? There was no vapor return line. And we know the importance for those operators that are operating LPG. You know the importance of vapor return line. Yeah, so none was provided. Yeah, there's one I did in Port Harcourt. They designed the plant, trucks will come to the gantry, and during the hazard, I picked up that and I asked them, for example, if I have a truck that comes to load and the truck is faulty or is leaking, I need to backload this product back to the tank. How do I do it? They didn't provide a backloading line. So it was during that hazard. But this ought to have been captured during design review. Now, it also depends on the facilitator. If the facilitator is not fast, not knowledgeable, a lot of things will get missing. The last hazard I did in Port Harcourt, we had a lot of recommendations. The operator, the designer was, I can say bitterness. It was a whole lot of them, bitterness, because there's a whole lot of things they didn't look at. And I said, I can easily tell you if a engineering design review is not done. You'll see so many recommendations. When the process engineers start taking us through the process background, you'll see a lot of issues. And one thing I need to say before we wrap up, I think it should be the last slide, second to the last slide. Please involve the right persons. Who are the right persons? People knowledgeable in the design, good operators, good engineers. It's not just about the guys, the manager. No, you could have some managers that are very good at managing people, but technically they are not sound. It is allowed. It's good. But let that manager delegate somebody. It could be somebody on the shop floor. I've done a lot of hands up. There's one guy in this company that is a very low guy in terms of cadre, but his contribution is superb. The manager doesn't play with him. Anywhere he is, he will ask somebody to go and replace him. Go to Ghana or go to different places. He has to be there. So it doesn't really mean that the manager, as a matter of fact, when engineering design review, sometimes the presence of management staff will spoil everything, because people will not be able to contribute. Only body language to keep their mouth mute. And when you do this during operation, you will have issues. Okay, no provision for isolation of what? The F100, which is the filter, and the drain. So it's very important. When you have finished your engineering design review, you come up with a report. Then what do? You have to track all the changes. It's one of the best value adds engineering team. of the best value add on engineering team can provide to their client. The technical review during critical design process, right from concept to what? To detail engineering design review. If you have your right team, I'm always using the word the right team. I've done so many of them where you have accountant coming for a business development manager coming to attend PhD design engineering review just because it's outside their location, just because there is what's it called, attestation allowance, flight, there's book, a whole lot of package because you are leaving your location. If that becomes the focus, then we're not going to get it right. During tea break, you see everywhere it's filled up. When the main hazard or PhD or engineering design start, the vanish, you won't see a whole lot of them. During lunch, they come back. No, that's not the right thing to do. So to cap it all, it is very important. We integrate engineering design review in our spectrum of engineering studies. And for us to get this done, we need to document that. We need to have this documented and signed off so that we know when we are here, the next stage everybody knows is engineering design review. You can also do a peer group review. You bring other people from other departments to review what you've done. But it is important if you bring an external person that is not your company, because you are not going to appraise a person, but you are careful when you are within, appraiser is next month, your supervisor is giving you body language, now you are still sharpening your mouth and all that. And when you remember the appraiser is next month, or he tells you jokingly, but that's he meant it. So boy, I hope you know appraiser is next month. That is the word. I've seen that happen. Then after break, when he comes back, that same guy that is on fire becomes very quiet. The importance of engineering design review in ensuring the better PhD and plant design cannot be overemphasized. It's going to reduce rework. It's going to ensure safety. It's going to ensure seamless operations, and the overall going to prevent that. And stakeholders will be better in terms of yielding or benefiting or reaping their dividend for those that have invested in that. Thank you. So I will entertain any question, answers, or comment at this point in time.
Thank you very much, sir. That was a very deep one. Definitely, we know that topics like this are very broad, and it takes expertise to be able to bring up so many things within few minutes, even though with the up and down with the issue of network and the likes. Thank you so much for your time, sir. What I would advise is, and what I would also like to say, is for professionals to know that HSE, or what we call safety, is a very wide industry. You can see that most of us that have been in manufacturing and majorly construction will find this very advanced to assimilate, to tell you that that is a complete field on its own. So you have a lot of opportunities in safety. And Mr. Emmanuel Kudo happened to be an expert in the field, not only practicing, but also training. So which means that if you would like to walk along this path, it's a very interesting field. Process safety, you can see the designing, the ASOP, the EDR, engineering design, the teamwork, the brainstorming section is always very interesting and engaging. So if you find this very valuable and you feel like this is the kind of field that you also want to find yourself, regardless of, yes, they might say you should have a science background, but I will tell you that if you could have a mentorship with someone like Mr. Emmanuel Kudo, and it takes you through this process, and you go through his training and have the opportunity to engage in practical activities, I'm very sure that you have a whole lot to do. Like you said, we need experienced people in every part of safety. Safety is very wide. 1 person, 2 persons, 10 persons cannot do it alone. So thank you so much for taking your time to, within your busy schedule. I know how busy you can be. I know how we're pushing for this over time, and you're always busy, and busy. But thank God you're able to find time for us today. We really appreciate you for taking your time to come to us today. Thank you so much. And hopefully, we know definitely we will still have opportunities to learn from you. So if you would like to know more further or to study further when it comes to process safety, Mr. Emmanuel Kudo from DN Sheffield, he takes courses, advanced courses on different topics, different areas of process safety. So you can chat him up anytime. He's open to conversation. He's a very free man, open door policy. Talk to him, discuss with him what you need. You can recommend training for you that you can attend. And trust me, it's not going to be for free. Yeah, I know sometimes it does scholarship for people, but if you really want to gain and you want to be in this field of process safety, our advice that you're ready to go through the process. Nothing good comes easy. Thank you so much, sir. If you have any, at this point, if you have any question, please let us ask a question. Please, if you have any question, please kindly raise your hand. Time is fast spent already, and we know Mr. Emmanuel, like he said, he just lodging into an hotel, so we might not want to take much of his time. Okay, Mr. Andrew Abanom, Engineer Andrew Abanom, over to you, sir. Powerful.
Yeah, very good evening. Please confirm you can hear me, Waliu.
Loud and clear, sir.
I can hear you, sir.
All right, thank you very much for having me. Just to quickly mention that many thanks to Coda Safety Consult for organizing this webinar, and much regards and thanks to Engineer Emmanuel Kudo, who is a fellow of the NI Safety. It's always a pleasure listening to you and learning from your wealth of experience. I don't really have a question, but just to make some commendations and comments based on what we have enjoyed from the meal this evening. Yeah, thank you. And I'm particularly happy when you had to bring in the delineation between the OHS, Occupational Health and Safety, and Safety Engineering, because they may have so many things in common, but when it comes to the practicality of safety engineering, we saw it very clear from your presentation, and the role of those as risk management tools and drawings. And I also like to quickly refresh our minds with the safety beacon of May and July 2024, which I've also seen on the platform of the Process Safety Forum. You know, those failures, they have been linked to errors in P&IDs, and things like the engineering design review could have picked those flaws, and but that was not done, and it resulted in a process safety accident. And you know, I must say that we are privileged to have you in the industry, and as also a fellow of the Nigerian Institution of Safety Engineers, bringing us this webinar. And we're also aware of how you have been helping our members in terms of coaching and bringing them to hands-on sessions to upskill them. That is very much appreciated. And for Coda and Emmanuel as well, our ask from the institution will also be that you continue to support our members, and when you have opportunities like this, and when you have practical sessions that they can learn from, it's also good that we know, and we also give our recommendations to you. And in terms of also giving concessions, we also plead that you will recognize the institution if they want to recommend members that will require concessions for your training sessions. I'd like to say thank you very much once again, and I appreciate Kuda Consult, and very importantly, Engineer Emmanuel Okudo for bringing us this webinar this evening. Thank you very much.
Thank you very much, sir. In fact, That is well understood beyond the words that you have used. It is well detailed and understood. And that reminds me also, it's also a very wonderful privilege to be within the platform of the Nigerian Institute of Safety Engineers. So you all, apart from what you have seen today, NISAFTE, there's always different, they have different branches, different states that they carry out technical sections on technical issues in Lagos, in Akwa Ibom, in Port Harcourt. Almost all our branches we carry out technical sections. So you can also join NISFTE to benefit a whole lot from what you have benefited today. And once again, if you want to get to know more about process safety, which I feel is very important, because when accident from process safety happens, it's always very disastrous. It's not the like of and safety that will have slip, and fall. Once a disaster happens in process safety, it costs a whole lot. So there's a need for us to also venture into this. If you want to know more, you can chat Mr. Emmanuel up. He has sent his details to the group. And if you want to contact him, you can also contact me directly to send you his number and for you to have more experience and more knowledge and expertise in this field. Like I used to tell my colleagues, my young professionals, it's not a casting stone. It's not what you start once in a day and you get to know it. You need to keep investing. With time goes on, we become what you want to become. Don't wait till you say you are ready. There's no other time to start than now. The best time to start was 5 years ago. The next best time to start is now. So you don't delay. Take the opportunity to get mentored by this expert and also join the NISFTE if you want to continue to be on this field. So because of time, we would not be able to go into question and answers again, like we have asked a minute ago. Mr. Emmanuel Okudo, please kindly pardon us. We would have presented your certificate to you, but definitely we are going to communicate it to you in a couple of days, your certificate for taking your time to come and educate us today, of appreciation, to appreciate you for your time, and that is coming from Cordal Safety Consult. Thank you so much, sir. I really appreciate you. So in line with that, and without further ado, we'll come to the end of this wonderful